Hello and welcome to the video series Runtime Analysis of AUTOSAR Embedded Projects. My name is Florian Sommer and I'm responsible for the business development for embedded software here at Vector Informatik in Stuttgart. This is the first video of this series and it focuses on timing problems and different classes of timing analysis. So it's kind of an introduction video to this topic in general. So first of all, which different kind of timing problems do we see in ECU projects? Let me give you an example on that. So in general, if you're talking about ECU projects, you usually have many different software components that you need to integrate into this ECU. And then somehow, most times at the end of the project, you will see that you have some issues with timing. For example, you could see that the system that you have is completely overloaded. So you're very close to 100% CPU load, which might cause different functional tests to fail and so on, because not all tasks are executed as you expect them to be. And now your task somehow is to find the root cause of this, to find out what is causing this high load and how are the different parts of this ECU interacting with each other. So with these multiple software components integrated and a high CPU load, you very often have the problem that you can't really determine where is the load coming from. So which task is causing a high load? Is the high load caused by software that was developed by my own company? Is the high load caused by the basic software that I'm using, by a misconfiguration, or is it caused by other applications that have been deployed from third-party vendors? So we want to find out what leads to this high CPU load, and at the same time, of course, we want to make sure that the CPU load and also other timing related requirements, like for example, the activation of tasks is as we expected and that the tasks keep their deadline, as well as event chains, for example. So if you have 3 different tasks, for example, where one task is reading sensor data, a second one is processing these data, and the third task is doing a decision based on the input that it gets, then you might want to make sure, first of all, that you really keep this chain, that you execute them in the right order. And additionally, you want to make sure that from reading the sensor data until an action happens, you don't take more than 1 millisecond, for example. So that would be an event chain. And how can all these requirements be tracked? In order to get to that point, we will first of all need to spend a little bit more time on the theory part and understand how different tasks can change their state. So let's have a look at the different states that the microSAR OS is providing. We have here a running state. So this means the task is actively running on the core. The task can also be preempted if another task is running on the core because it has a higher priority. And in the end, somehow it will be suspended until it gets activated again. If we have a look at this on a timeline, then it would look like this. So at the time point of 1 millisecond, your task is getting activated, but it's not yet running on the core because other tasks are still running. Then at the time 2 milliseconds, this task is getting to run on the core. After 1 further millisecond, after 3 milliseconds, it's now preempted because another core is interrupting the activity. And then finally it gets running again, and afterwards is suspended because it's finalized until it will get activated again. So that's what I mean when I'm going to talk about scheduling traces and a timeline in the further steps of this video. Let's now have a look at the different classes of real-time analysis. Let's start with a very simple and easy method, which is the sampling. So by sampling, you can quantitatively analyze different tasks and ISRs by having a look at their state in different points in time. So depending how frequently you sample the information, you get a more or less detailed picture of that. The next possibility to do some kind of timing analysis is statistics. So with statistics, you will get the information, what is the minimum, what's the maximum, and what's the average runtime of a task. And you will be able to determine the CPU load that a task is causing on your system. The third class that we are going to talk about in this video is the timeline that you measure with a profiler. And here you get the complete timing metrics. So here you will be able to see for all tasks and all runnables a timeline like I've shown it in the slide before. And you will be able to have a lot of different metrics. So you will be able to see the start delay. So how long is my task activated but not actively running on the core? You will be able to see how long is it preempted. And you will also be able to analyze things like the event chains I mentioned in the early beginning of this video. At the end of this video, I want to offer you some possibilities to stay in touch and find out more about timing analysis. For that, I'm inviting you to join the LinkedIn group Runtime Analysis in AUTOSAR projects. In this group, you will meet other people working in this field, sharing their experiences and solutions for this topic. And you will, of course, also be able to engage in discussions and ask your questions there. Just search for the group directly on LinkedIn, or if you want to have it easier, I put a QR code here in the video so you can simply scan the QR code and you will be redirected to this group. Would be happy to have you in the group. If you have questions to me directly, or if you want to connect with me, I'm inviting you to scan the QR code here on the right. You can also see the link to my profile here on LinkedIn. I would be very happy to connect with you and answer any questions you have. Thank you very much for watching this video. I'm looking forward to stay in touch with you.